Howdy there, Texas Pelicans, and welcome to our channel. Today, we are going to be doing a demonstration on creating a HEC-RAS model from scratch for the Texas projects, utilizing the TNRIS, which stands for Texas Natural Resources Institute. For Texas, and we're going to use their elevation data as the base of our model, and we're going to put it in state plane coordinate systems as we do for most of the projects that at least the Pelicans work on. So we are going to get started with that demo. So let me start by sharing my screen. This is actually the second time I'm making this recording. The first time I forgot to do that. And that's kind of important when showing how to do things. So let's start by taking your internet browser, going to tenris.org, and then we will go to data and maps over here on the right side. Let's go to the data hub and load that up. It comes up with a map. We're going to zoom in to our project. I started off by doing a demo of a project that we actually have. I might change it up a little bit and do another the same creek, but maybe something somewhere else in that area, because it was a little bit of a long section, and I just want to do something different since I'm repeating this. So we're going to zoom into our area that we want, and then we're going to hit this draw search. We're going to click once and click again, drawing a box over our area. Finally, we're going to click on filters and go to elevation, and we are going to look for the best elevation data we can get. In this case, it's this 2017 LiDAR from the Neches River Basin. So I'm going to click on the LiDAR button here, and it's going to make me zoom to a more specific area when I do that. So when that loads up, we will select the specific LiDAR tile that we are interested in. It is here in Lindale, Texas. And let us go ahead and click on this one. And then let's get the digital elevation model. I'm going to click download here, and it's going to start downloading. I actually already have that, so I was just doing that for a demo, so we won't worry about waiting for it. The other thing we are going to need, and I thought I had it open. Let me see. We are going to need a projection for our project. So for that, I will include this. This has been a useful link that's got all the Texas state plane PRJs that we could use. So we are going to be in the north central zone, NAT 83 state plane, Texas north central. And what I want is this PRJ file. So I'm going to click on that, and it's again going to start downloading. But as you see, I've already downloaded that. That is a quick download, but we don't need to wait for it either if it was longer. Now let's get started with HEC-RAS. So I'm going to open an instance of HEC-RAS version 6.3. And I'm going to start a new project. So I'm going to go File, Save Project As. And I'm going to I always save my project under a folder based on the version they're in. And let's go ahead and create a new folder in here under 6.3, and let's call it Prairie Creek Demo 2. And let's do that and call it Prairie Creek. So in this video, I'm going to try to show you all the steps for building just a basic RASMAPPER HEC-RAS file, 1D file, starting with RASMAPPER and getting it to run. So to get a 1D model to run, what you're going to need is a steady flow file. which we will come back and create later, and a geometry file. So let's go ahead and make a geometry. Let's go and hit this button here and go ahead and make sure I'm sharing my screen. All good there. Just had a moment of, oh, not again. But here we go. Let's do files, save geometry data as Prairie Creek. Let's call this existing and say okay. Let's go ahead and close it out once we've created it. And then let's open this flat earth button looking thing here, kind of in the middle of the RAS. And let's go here. Hopefully the lawn guys in the background aren't too loud this morning, but they should be done pretty soon here. So we got that in there. The first thing I'll want to do is set the projection for my project. So let's go project, set projection, find the projection file that we just downloaded. It's going to be in my downloads, and I will select it here. And that will give it the North Central Texas coordinate system that we want it to be in. And I'm going to say okay. And the next thing we'll do is build a RAS terrain. So I'm going to go down to terrain here, right click, create a new RAS terrain, and we're going to click the plus button to add the data. And we're going to go to where we just download this Neches River. I've already downloaded it and unzipped it previously, which you will have to do after downloading. And let's grab all these image files and load them in. This TNRIS data that I got is in meters, so I want to set the vertical conversion. It's probably default going to be this, and you want to change it to feet, meters to feet to get the right elevations in feet that you want. Finally, we want to merge all this into a single raster to make things easier in the model, and it'll create this terrain.hdf file for you. So let's go ahead and hit create and give it a minute, and it will process for a little bit, and then it will create your RAS terrain for building geometry. It's almost done there, and it is done. And there we go. I'm going to save this. Sometimes I'm going to save it and see. Sometimes it takes this a while to pick up the terrain data that you've put in there, but I'm going to go to right click. We don't have anything in there. I'll come back to that. So we need to get some geometry in before we start messing with that. So let's go back to the RASMAPPER. And now that we have the terrain in there, we've got the coordinate system set, so we can go ahead and add a web imagery layer if we'd like. Let's go ahead and select one here. We can do the Google hybrid. That will be nice. And then we don't see our terrain anymore. If we want to see both, we can go to the image display properties under the Google hybrid, go here and set our transparency to about something like that, and say okay. That should allow us to see the terrain as well, and then we can edit the image display properties on the terrain, have some plot contours, maybe have 1 foot, and be able to see things more well defined there. As we're doing these RASMAPPER steps, it is going to be better to turn off the Google hybrid once we get going. On the previous one where I was attempting to do, I did our actual project location, which was a creek through I-20 here, which is great. I'm going to do something a little bit more simplistic so that the creating of geometry will not take as long for the pointing and clicking, and I'm not going to worry about the bridge, but you will do this for wherever you are trying, whatever reach you are trying to model, and you will get things set up. So let's go ahead and I'm going to work on this stretch in here. That'll be nice and simple and hopefully a little bit faster to show you just the process that you will take. So let's turn off Google Earth so I can see things more clearly as far as the terrain definition is concerned. And then let's click on this geometry, and then let's click on the edit geometry button right here. That will populate all the levels that we can start to edit. We will start with the rivers, and we will go ahead and we are in editing mode, and we will start laying out our creek. This creek flows from north to south here on the screen. And when you're in HEC-RAS, you are always thinking as if you are in a boat and you are going from upstream to downstream. So we want to start at the upstream end and draw going to the downstream end. So let's go ahead and get started here, and we'll just start laying out sort of quickly along the flow line of the reach. And dun, dun, dun. So there it is right there. That's my river. Want the name, I can give it the name of the actual creek if I'd like. So I can say Prairie Creek, and I can say okay. And then now that we've got the river in, the next thing we can add in is the bank line. So let's go ahead and switch to editing that level. Grass is pretty smart. I don't think the river, it does matter which direction you draw it in, so make sure you draw it in upstream to downstream. The bank lines, I don't know if it matters, but I always start with just HEC-RAS thinking, left side first, going left to right, looking downstream. I'll start with my left bank. Really, I don't think it would matter whichever way you did it, but better safe than sorry, right? So I don't feel like experimenting with it at this time, but let's go ahead and draw in our bank along the defined bank based on the contours. So the better your LiDAR data is, the easier this is. There we go. And let's do this. Now we're doing the right bank. So let me delete that one. As I was thinking about it, I was like, it's probably more like this. Then we just go along this bank line all the way to our downstream end of the model. Now we need a flow path. Flow paths are used to, when we draw our cross section in, the model is going to calculate the main channel length from the cross section to the downstream cross section based on this line, and then it's going to calculate the leftover bank length based on my flow path line. And the general rule of thumb is to draw this flow path line approximately 1/3 of the way to where the floodplain boundary is from your bank line. So I have a general idea of how wide this floodplain is, I think. So I'm just gonna say it's probably out here somewhere, maybe out in here where it starts to get more green. So I'm gonna start just estimating the flow path, something like so. And this is not precise. If you're way off and the floodplain's really only here, you may redo these lines, but all this is used for is, or if it's way out here, then you may adjust your lines and rerun it, but it's only calculating the length between your cross sections on those overbanks. So let's go ahead and draw in for the other side approximately. So if this is the floodplain width, somewhere at this yellow green near that, then it's a little less wide in here, so it would be closer to the bank. But we are just using this. And now we're going to draw some, we got the bank lines, we got the flow paths. The next thing we're going to do is some cross sections. So let's go ahead and start editing that. Again, we are in a boat. We are looking downstream. We are starting from left to right. It is important which direction you draw your cross sections in. So you want to start at the left side, and then you want to be perpendicular to your contours as you do it, and also perpendicular to the creek as you cross it. So we are going to do, you know, something like so. We can try to get some cross sections close to some of these bends, maybe one in this bend here. Put as few or as many as you like. And there's a lot of resources in the HEC-RAS user's manual that gives some general information about laying out cross sections. That is really good. I'm just kind of eyeballing them here. Spacing feels pretty good here. I'll put a few more downstream. Something like that. And now I am going to, the next thing I'm going to do is go to right click on the cross sections, go to update cross sections, get the elevations from the terrain. I think it will automatically do that, but just in case, we'll go ahead and tell it to do that. And it says geometry association was set to the first available terrain. All cross sections have been set to cut from the terrain. They will cut as needed or whenever you save the geometry. That's great. That's what I wanted to do. The next thing I will do is update the cross sections and all these attributes. You can select one at a time. We haven't done anything yet, so we want to do all of them, and it will get the river stations, the bank stations based on where we drew the bank lines, the reach links based on where we drew the channel, and flow path lines. There's also options for adding in ineffective areas and blocked obstructions, but we haven't done any of that. So I will just go ahead and hit all cross-section attributes, let it run. Then I'm going to stop editing, save the edits, and I'm going to hit save. And I'm going to go back to the main geometric data editor. And I'm going to right click in here, do a full plot, and it should zoom in to where we want to be. If I want to zoom, so it is all there now. And that's where I want to be. I do want to kind of see a little downstream of this. I'm going to go back to RASMAPPER for a second. Maybe see if I can just kind of I have not, if I figure out how to do this, I might drop it in the comment section. And I think maybe it's something with this version, but modifying is not super simple with RASMAPPER. There should be something to edit the vertexes being here, but it seems to only let you edit by dragging, which is not at all what I want to do. I just want to edit a vertex. Let me just add in, I don't think it'll hurt anything. Let me just extend this flow path line so that it will show me a little more limits in the plot itself. And let me save that, stop editing, save edits, file, save again, and go back here and do a full plot again. It's still well, this is gonna have to work. Let me see. View, there's options, view options. Let's go to view, set. This is not the way I want to do it, but it's going to work. Set schematic plot extents, since I want to see a little more. It doesn't always do this. It sometimes just shows you the limits of what you want. So I'm just going to left extent. I'm going to make that a little bit smaller so I can see more. The right extent a little bit bigger, maybe 5, and then top maybe make that a 7. Just kind of bump everything, and bottom I want to make that lower, so I want to make that a 7 as well. So let's do that, and that kind of, I really want to set the bottom a little bit lower than I did. So let's make that a, let's keep it at 7, and let's make that a 3. Guess at that. No, not enough. Let's do that as a 6. There we go. That should be good enough. So now we've got the geometric data in here. If we open up the cross sections, we see it's got our reach links in there. It's got our bank stations assigned. That's all good. It doesn't have many in values. There is a way to build that in RASMAPPER. It's a little more time consuming because you have to first give it a land use layer. So I'm not going to do that today. I'm just going to set up a basic model, and we're going to assign in values. So let's go to options and let us turn off this horizontal variation. There might be a quicker step for this. I did not see a way of automatically turning that off for all the cross sections so that we could update it all in a table, but we will be able to, once you uncheck this, update all these mannings in a table. So let's do that. There we go. We've hit apply. Now we can go to tables, mannings in. They don't have anything set for them really right now, but let's do this middle one is the main channel. Let's give it 0.05. And these are the left and right overbanks. Let's give those 0.07. You will, of course, base that on your land use in the channel and overbanks and the vegetation and all that. So let us do this. And get that, copy there, hit OK. So now we've got all that. It's got the reach links, except for it won't have the reach links for the bottom cross section. And let's just give it, I like to give it a little bit of a reach link there, and it will use the normal depth slope that you set as your boundary condition for calculating that. It might run without that, but this is just something I generally do. And let's hit apply. I think it needs some kind of downstream reach length. So let's go ahead and hit apply there. The next thing we will need to be set up to have a working model is going to be our steady flow data. So let's go there and say, I have a general idea based on, this is a stream that we've actually done a HEC-RAS model for a project. So I'm going to give it some flows, kind of guesstimate. It is somewhere around 6,000 CFS that we're using for the 100-year in our project, a little bit higher than that, but we'll go ahead and enter these. Just kind of guess some flows to show you how it works for now. Lastly, we will need a boundary condition. Let's go ahead and save this flow data. Prairie Creek existing, and hit OK. And we will need a boundary condition, which we will set as a normal depth, typically in most cases, unless you're coming into a major creek that you want to give it a known tailwater water surface elevation. So we're going to do that. Let me show you a quick trick for getting that normal depth slope. If you go into your geometric data, and then we are wanting what is the slope of the stream at the downstream end for that normal depth slope. So let's go ahead and hold down the control button. It's going to pop up this measure tool, and then we are going to come here and click along the stream. If you go down a little ways, it'll give you a more accurate reading most likely. And then what you're going to do is hit this cut profile from terrain plot, and that's going to show the profile of things. Now you get a lot of bumping up and down. That's because it's probably not following the creek bed exactly at every location. But if you look at the lower elevations on this, that is most likely the creek bed. So hold down the control button again, the measuring thing will pop up, and then hit at one of these lower elevations at the beginning, and then one of the lower elevations at the end. And that's going to give you this delta x, the dydx, which is the slope of your channel in feet per feet. So I'm going to go ahead and copy that. Then I'm going to go back to my normal depth conditions that we have here at the downstream end. I'm going to double click. I'm going to click normal depth, and then I'm going to hit that. Hit OK, hit OK. I'm going to save my steady flow data. And finally, we are going to open your plan manager, which when you're navigating through HEC-RAS, you always want to use the plan manager to keep organized once you have everything set up. So a plan, it basically relates a geometry file to a steady flow file. So we're going to give this plan a name now that we got it set up. We'll call it Prairie Creek Existing as well. And then we are going to go give it a short ID and give it a description if you want. We should be able to run the thing. So let's see if it runs. Everything's good. So finally, everything ran. We can kind of take a look and do a sniff test on these water surface elevations. I know just downstream of here in our actual model, the elevation is around 435. We did run this with a little bit less flows, and this is a little farther upstream. So it makes sense since it's farther upstream that it's a little bit higher. So I think it's generally doing what we want it to do. We can also open up RASMAPPER and go to our results layer, and we can see the water surface. We can, that's for profile 1, we can see it. That's one of the lower flows. We can also go to right click in here, click create a new RASMAPPER results layer, do water surface elevation, do the higher one, add to the map. We see that one is a little bit higher than that one. And so we can also go and add another RAS map layer, and this will be able to bring into Google Earth. If you click on this inundation boundary, let's do it for the highest profile that we did, and click add to map. And once you do that, you close that out, and then you right click on it and say compute updated stored map not created. Click on that, it does some calculations, and then it shows the inundation extents of your mapping. So let's go ahead and export that out to a KML file, and we could say Prairie Creek Pelicans demo. And then we should be able to find that in our file navigation somewhere. I think it was in C drive under HEC-RAS 6.3. And where did it go? It went to I-20. It was in this folder. There it is. So we load that up. This lower one was the one I did for when I was not sharing my screen. So I'm re-recording this, but this is the inundation level for what we've just done here. So that's a useful feature that you may want to share the information about how much the flooding extent is with some other disciplines in the project. So that is a cool feature. From here, you can also export this to a shape file, or maybe that is within RASMAPPER itself, I believe. You can go to export to a shape file, and that is also handy for design. So with other tools, we did not get to it in this video, maybe in some other ones, but you can also use the tools to set up bridge cross sections in here if you want with your geometries. You can go here, cross sections. You could do, see, where are the other layers? So merge cross sections. I could be wrong about that. I don't think so though. Let me just look for it since I said that. I know you can in when you're doing a 2D model. I thought you could in 1D as well. Cross sections. Oh, maybe in here. Generate layers. Maybe not. Sorry, false hopes. I thought you could, if you did have to add a bridge, you could do it in the just the typical way you would do by adding a bridge structure here and giving it a station in between the cross sections that you wanted to do. We will probably have some other videos on that. I know if I find that, I may put it in a link on the steps to do that, or put it in the description later on. I thought you could do it in 1D straight through here and adding the bridges and culverts and getting those started, the locations of those and getting those started within RASMAPPER. Anyway, thanks for joining. If you enjoyed this video, please remember to like and subscribe to our channel, and we hope to see you in the future. Have a good day.